Assalamu alaikum. I am Dr. Saeed Ali Mardan Azmi. Welcome to my channel. In this lecture, we will learn exercise 16.1, question number 9 to 13, Thomas Calculus, 12th edition book. And first of all, we will learn what is a line integral. To calculate the total mass of a wire along a curve in space, or if we have to find out the work done by a variable force along such a curve, we have to use line integral. Here is a curve which start from point A and ends at point B, then R of t is a smooth parameterization of this curve in the three-dimension plane. Then, in order to calculate line integral, we will have to apply this formula. In this formula, to integrate a continuous function f of x, y, z over the curve C, this curve C, what we will do, we will find out the smooth parameterization of C, that is R of t. R of t is equal to g of ti plus h of tj plus k of t k. For the limits a to b, here the limits of parameter t are between a to b, where a is the starting point and b is the ending point of the curve, where we have to calculate this line integral. And then we will evaluate the line integral as integral over the curve C f of x y z ds is equal to limits from a to b f of g of t, h of t, k of t into v of t mod dt, where v of t mod is derivative of r of t with respect to t. Please note that in this calculation, a and b are actually the limits of parameter t. Now, how we have calculated this function? Actually, in order to calculate this function, we have converted our function in the form of t. Please note that g of t is actually the value of x, h of t is the value of y, and k of t is the value of z in the form of t. So, in order to calculate the line integral, we have to follow two steps. In the step number 1, we will calculate v of t mod, means smooth parameterization of the given curve, and then we will calculate its derivative. And after calculating the derivative, we will calculate its mod. And in the second step, we will parameterize our given function, and then we can evaluate the integral in the third step. Since we have to calculate the line integral, we must know the parametric equation of straight line, because straight line is widely used in this concept. So what is equation of straight line in parametric form in three-dimension space? And here it is. X is equal to x1 plus t of x2 minus x1, y is equal to y1 plus t of y2 minus y1, and z is equal to z1 plus t of z2 minus z1, where x1, y1, z1 is your starting point and x2, y2, z is your ending point. Please note that in equation of straight line, or whenever you have a straight line segment between 2 points, the value of parameter t always lies between 0 and 1. Now, we are able that we can solve the questions from the exercise. Now, what is the statement? Evaluate line integral over the space curve. And in question number 9, it is given to us evaluate integral over the curve C x plus y ds, where C is the straight line segment, whose parametric equations are x equal to t, y is equal to 1 minus t, from 0, 1, 0 to 1, 0, 0. Since the value of z is not given, so we will take it as 0. Now, this is a generic formula of R of t. R of t is actually xi plus yj plus zk. So, in order to calculate its parametric form, we will substitute the value of x, y, and z in this equation. And please note that in question number 9 to question number 13, we have to follow 3 similar steps. So, in step number 1, we will calculate R of t, and then after calculating R of t, we will calculate V of t mod. So, in order to calculate R of t, I have replaced x with t. That's the value of x is t. The value of y is 1 minus t. I have replaced it here. Since z is not given to us, so its value is 0. In the next step, taking its derivative with respect to t, the derivative of t is 1. The derivative of 1 minus t is 0 minus 1. And derivative of 0 is 0. So, this is derivative of r of t with respect to t. In the next step, making the simplification. And after this, we can evaluate v of t mod. Now, v of t mod is actually dr over dt mod, and it can be calculated as I coefficient square plus j coefficient square plus k coefficient square whole square root. So after calculation, we will get its value, v of t mod is equal to square root of 2. And this completes our step number 1. In step number 2, we will parameterize our given function. Our given function in the integral is x plus y. So substituting the value of x and y in the form of t, we will get f of r of t equal to 1. F of r of t means we have substituted the value of x, y, z from this r of t. So after calculating these two things, we can use the formula of line integral as limit from a to b f of r of t into v of t mod dt. I have written this formula in a simpler form. So substituting the values here, the given function is x plus y ds, and in this question limits are 0 to 1 because the line segment is a straight line. The value of f of r of t is 1, the value of v of t mod is square root of 2, and dt remain as it is. In the next step, we will calculate it. Square root of 2 is constant, we can take it outside, and integration of dt is t for the given limits 0 to 1. Next step, applying the limits, upper limit minus lower limit, so the answer of line integral is square root of 2. And this completes this question. Now, question number 10. Evaluate the given function for the straight line segment x is equal to t, y is equal to 1 minus t, and z equal to 1 for the points 0, 1, 1, 2, 1, 0, 1. Please note that since we have a straight line segment, so limits of t are between 0 and 1. So step number 1, we have calculated r of t as the value of t, the value of x in the form of t is here as a coefficient of I, the value of y in the form of t is here as a coefficient of j, and the value of z is here as coefficient of k. In the next step, calculating the derivative. Derivative of t is 1, derivative of 1 minus t is 0 minus 1, and derivative of 1 is 0 with respect to t. Making the simplifications. And the next step, calculating the square root. Calculating the v of t mod, we get square root of 2. After this, we can move on step number 2. In step number 2, we will convert our function in the form of t with the help of parametric values of r of t. The value of x is t, the value of y is 1 minus t, and the value of z is 2. So after substituting the values, making the simplification, we get 2 into 2t minus 2. So after completion of step number 1 and step number 2, we will calculate the line integral. In order to calculate the line integral, we have substituted the values in the given function. The limits are 0 to 1. The value of function we have calculated is 2t minus 2. The value of v of t mod is square root of 2. dt remain as it is. In the next step, I have taken 2 common from here, and square root of 2 is also constant, so we can take it outside. So we have taken outside 2 into square root of 2, and we are left with t minus 1 for the limit 0 to 1 dt. In the next step, integrating. The integration of t is t squared by 2 minus integration of 1 is t for the given limits. In the next step, applying the limits and making a simplification, we will get our answer as minus square root of 2. And this completes this question. Next, in question number 11, we have a function. Integrate xy plus y plus z along the curve r of t is equal to 2ti plus tj plus 2 minus 2k, and the limits given here are 0 to 1. So working steps are similar. Step number 1, since r of t is given directly, so in the next step we will calculate its derivative. Derivative of r of t with respect to t is derivative of 2t with respect to t is 2. Derivative of t is 1, and derivative of 2 minus 2t is 0 minus 2. Making a simplification, in the next step we will calculate v of t mod by taking the mod of this dr over dt. So we have I component square plus j component square plus k component square whole square root, and we get v of t mod equal to 3. This completes the step number 1. In step number 2, we will convert our function in the form of t by using r of t. In r of t, the coefficient of x is 2t, so the value of x is 2t. In r of t, the coefficient of j is t, So the value of y is t. So I have replaced x with 2t and y with t. The coefficient of k in R of t is 2 minus 2t. So the value of z is 2 minus 2t. After substituting these values, we will make the simplification. So we get 2t squared minus t plus 2. And this completes the step number 2. After step number 2, we can move on step number 3. Now we will replace the values in the formula of line integral. The limits are between 0 to 1. The value of f of r of t we have calculated as 2t squared minus t plus 2. The value of v of t mod we have calculated in the previous steps is 3. And we will integrate it for the variable t. 3 is constant, we can take it outside. The integration of 2t square is 2t cube over 3. Integration of minus t is t square over 2. And integration of plus 2 is 2t. Applying the limits, upper limit minus lower limit. When we apply lower limit, all the terms become 0. And for upper limit, we have replaced t with 1. Making the simplification, we will get our answer as 13 over 2. And this completes this question. Next, in question number 12, function is given to us along the curve whose parametric equations are r of t is equal to 4 cos of ti plus 4 sin of tj plus 3tk for the limits minus 2 pi to 2 pi. Step number 1, r of t is given to us. We will calculate its derivative with respect to t. The derivative of 4 cos of t with respect to t is minus 4 sin of t. The derivative of cos is minus sine plus derivative of 4 sin of t is 4 cos of t and derivative of 3t is 3 into 1 which is 3. In the next step, we'll calculate v of t mod. So I coefficient square plus j coefficient square plus k coefficient square whole square root will give us v of t mod. Making the simplification, in the first two terms we can take 4 square outside. So we have sine square of t plus cos square of t, and sine square of t plus cos square of t is equal to 1. So we have 4 square plus 3 square. 4 square is 16 and 3 square is 9. 16 plus 9 is 25 and 25 square root is 5. So we have completed step number 1. In step number 2, we will convert our function in the form of t. In r of t, the value of x is 4 cos of t, the coefficient of pi, and from r of t, the value of y is 4 sin of t, coefficient of j. Substituting the values, making the simplification, we get our answer of f of r of t as 4. This completes the step number 2. After this, in step number 3, we will substitute the values in the formula of line integral. The limits are between minus 2 pi to 2 pi. The value of f of r of t is 4 and the value of v of t mod we have calculated in the previous step is 5. So 4 into 5 is 20. We can take it outside, and integration of t dt is t for the given limits. Applying the limits, upper limit minus lower limit, we get, actually this is plus. Upper limit minus lower limit, we get 2 pi minus 2 pi, minus minus plus, we have 4 pi. So 20 into 4 pi is 80 pi. And this completes this question. After this, we have question number 13. Question number 13 is different from previous questions because in question number 13, the value of r of t is not given to us. So have a look on this question. Find the line integral of f of x, y, z is equal to x plus y plus z over the straight line segment from 1, 2, 3 to 0, minus 1, 1. Now in order to solve this question, first of all, we will calculate the value of r of t. Since our path is a straight line, so we will use the equation of straight line in 3-dimension space. X is equal to x1 plus t of x2 minus x1. Y is equal to y1 plus t of y2 minus y1. Z is equal to z1 plus t of z2 minus z1. Now, in this formula, our starting point is 1, 2, 3. As I have stated earlier in the beginning of this lecture, the value of x1, y1 and z1 is our starting point. So I have replaced x1, y1, z1 with 1, 2, 3, and the values of x2, y2 and z2 are the ending point coefficients. So the value of x2 is 0, the value of y2 is 0, and the value of z2 is the value of x2 is 0, the value of y2 is -1, and the value of z2 is 1. So I have replaced x2 with 0, y2 with -1, and z2 with 1, x1 with 1, y1 with 2, and z1 with 3. So after simplification, the value of x is 1 minus t, the value of y is 2 minus 3t, and the value of z is 3 minus 2t. Please note that for straight line segments, limits are always between 0 and 1. The value of t lies between 0 and 1. In the next step, we will develop r of t with the values of x, y, and z. The value of x is 1 minus t, so I have 1 minus ti. The value of y is 2 minus 3t, so I have plus 2 minus 3t j, and the value of z is 3 minus 2t, so I have 3 minus 2t k. From the value of x, y, and z, we have developed r of t. In the next step, taking its derivative, and then from the derivative, we can calculate v of t mod by taking its mod. So v of t mod is I coefficient square plus j coefficient square plus k coefficient square whole square root. So the value of v of t mod is square root of 14. This completes the step number 1. We have calculated v of t mod. In step number 2, we will convert our given function in the form of t. So the value of x is 1 minus t, the value of y is 2 minus t, and the value of z is 3 minus 2t. We have substituted these values here. Making the simplification, I get 6 minus 6t. We can take 6 common. So the value of f of r of t is 6 into 1 minus t. So step number 1 and step number 2 are completed. Now we can evaluate the line integral. Limits are between 0 to 1 because our path is a straight line. The value of f of r of t is 6 into 1 minus t. The value of v of t mod is square root of 14. We can take 6 into square root of 14 outside, and we can perform the integration of 1 minus t as integration of 1 is t, and integration of minus t is minus t square over 2. For the limit 0 to 1. In the next step, applying the limits, upper limit minus lower limit, making the simplification, we get our answer as 3 into square root of 14. I hope you have understand all these questions. Please like, subscribe and share this content with your fellows. Allah Hafiz.